Hi, in this video we talk about acceleration. What is acceleration? The definition in your book is telling you that acceleration is a physical quantity that measures the rate of change of velocity as time passes. But what that means? To measure the rate of change of velocity, this means that the object is not moving with a constant velocity. The velocity changes either by increasing or decreasing. The velocity is not uniform. If the velocity of the object is increasing, we call that this is acceleration or positive acceleration. If the velocity of the object is decreasing, then in this case it's called deceleration. Why are we talking about velocity and not saying speed? Is there a difference between velocity and speed? Yes, actually. For now, the simple difference is that velocity is a speed with a direction, but we will go through more details in the coming videos. Another point that you need to know about acceleration. To accelerate is to change speed or change direction or change both, change speed and direction at the same time. If acceleration is the rate of change of speed, this means that the object can never move with a uniform speed. Uniform speed means the speed doesn't change or the velocity doesn't change. So if the object is moving with a uniform velocity or a uniform speed, this means that the acceleration equals 0. As we agreed before, acceleration is a physical quantity that measures the amount of change in velocity as time passes. So from this definition, we can see this rule. Acceleration equals change in velocity divided by the time taken. And most of the times we can take the definition and we can conclude the kind of rule that we will use to apply during mathematical problems. So acceleration, A equals change in velocity, which is delta V, divided by change in time, which is delta T. Delta change of. When I need to get the change of, this means that change of speed means that I need to subtract V2 minus V1. V2, which is the final velocity the object reaches, and V1 is the initial velocity which the object starts with, and divided by delta T, T2 minus T1. Now we need to know what is the measuring unit of acceleration. You do not need to memorize the measuring unit of acceleration. Actually, this is something that you can get or understand or conclude from the rule of acceleration. Take a look at this. Acceleration is change in velocity divided by time taken. So change in velocity is measured by meter per second, and divided by time taken, this is second. Meter per second. Meter per second belongs to change in velocity, and the second is the measuring unit for time. Or let me say that meter per second is the measuring unit for velocity, and the second is the measuring unit of time. Okay, so if I divided meter per second divided by second, so the measuring unit of acceleration equals meter per second square. We have an example now on how to calculate acceleration. We have two objects. We have object A that starts moving from rest and reaches the speed of 15 meters per second after 5 seconds of movement. And we have another object here, which is object B, also starts to move from rest and reaches speed 20 meters per second after 10 seconds. And he's asking me in this problem to see which object has the highest acceleration. This means we are going to solve this problem on two steps. Step number 1 is to calculate acceleration for object A. If I want to calculate acceleration, then I need to remind myself of the rule. Acceleration equals V2 minus V1 divided by delta T. What is the information that's related to object A? The initial speed, the object starts from rest, so the initial speed is 0. The final speed in this case is V2 equals 15 meters per second, and delta t equals 5 seconds. Acceleration V2 minus V1 divided by delta t. V2, 15 minus 0 divided by 5. The acceleration for object A equals 3 meters per second square. Now for object B, the same steps. I will put the rule in front of me first, because usually in exams, writing the rule is 50% of the mark on this mathematical problem. And then we get the information or the data related of object B. So V1 equals 0, because also here the object starts to move from rest. V2 equals 20 meters per second, and the times taken to reach the 20 meters per second after 10 seconds. So delta t equals 10 seconds. Acceleration equals V2 minus V1 divided by delta t equals 20 V2 minus 0, moving from rest, divided by 10, 2 meters per second square. This means that object A has higher acceleration than object